and it adds it to this current profile and then returns it. And for the basis of this talk, my nutrition profile class is a very simple class. It's really just values for things like proteins and lipids and sugars, etc. And it's just keeping track of them and then can write them out if need be. This is an example of what this code looks like when you execute it. So if you create a recipe that has 2 pounds of flour and 1 gram of nutmeg in it, and then you iterate over all these guys and add them, then what I've done is manually taken the flour and nutmeg, protein, lipids, etc., and then verified that all those guys get reported correctly. Now what I want to talk about is actually populating that nutrition profile database. And it might be nice if you created a nice fluent way to do this that maybe someone who's not even a programmer can actually put these things in. And you don't necessarily need a form or anything like that. This is a type of DSL called a business natural language, which means that it's something that some person that's familiar with nutrition profile stuff could probably type in. And what this says is ingredient flour has this much protein, this much lipids, this much sugar. Each row of this text file is going to have more stuff about nutrition in it. It turns out that that is a DSL. Because when you look at those lines in that text file and think about it, what is this really and how close is this to actual Ruby code? Well, the first line there could be the method call. That's the first parameter. Has, I'll come back to in just a second. And then the second parameters is really just a set of name value pairs. One of the nice things in Ruby is that you can define a method that takes in a hash, which is name value pairs. And if it's the last parameter, you don't have to construct a new hash. You can just pass them as name value pairs. Now, they're not quite syntactically legal yet. In fact, this is not quite legal Ruby code yet, but it's very close to legal Ruby code. And it's also very, very English-like. Now, has is a special case here. It's an example of what's known as a bubble word in DSLs. A bubble word, this is actually a pattern in DSLs, a bubble word is a word that don't contribute to the definition of the DSL, but rather to its readability. So the has is really there for someone to be able to read this and understand it. It doesn't really contribute anything to the technical meaning of what I'm typing in there. And the way that you handle this line of almost Ruby code is through this nutrition profile definition class. And I'm going to talk about several of the methods in here. And I'm going to start with this one, which is called PolishText. What happens when you get that definition line, you pass it first to PolishText. And so this is what happens, and I'll come back to the implementation of that method in just a second. So you have a bunch of code that looks like this, with my test text says ingredient flour has protein, lipids, etc., and a bunch of other stuff. And what you want to convert it to is this, which is actual legal Ruby code. So I need to replace has with a comma, and then change these into actual name value pairs in Ruby, which is using the little hash rocket instead of just an equal sign. And that's exactly what PolishText does. It takes that definition line and makes a copy of it, and then it does a substitution that says, okay, every time you see an equals, turn that into a hash rocket. You can also put and in there between each one of the ingredients. And that's another bubble word, so it just bubbles that away and makes it go away. Has actually becomes a comma, so that becomes the separator for the first and second parameters. And then ultimately you return this polished text from this method. So what it's doing is very lightweight substitutions to convert this almost Ruby code into actual Ruby code. Once you've done that, you now have, by the end of this method, you have a legal line of Ruby code. And the next step in this process, in this method, is process definition. Takes in that definition line, and it calls instance eval on PolishText, which is returning you that line of now legal Ruby code. So what you're actually getting on instance eval is this: ingredient, flour, comma, and then name value pairs as a hash for the rest of those values. Because we're using instance eval here, that means that this is going to be calling an ingredient method on this nutrition profile definition class. That's what instance eval does, is it says, okay, anything that's executed inside this instance eval, then self becomes whatever class you're within. And I'm in my nutrition profile definition class here. And so the method that's actually going to be called here is this one. Ingredient, that takes in a name and then a hash of ingredients, and it actually calls a helper method on nutrition profile, create from hash, which takes in name and ingredients, and that's what actually creates each one of those records in that nutrition profile database. Here's an example of a unit test that actually does that. Now you'll notice a little bit back that I used the same constant missing factory trick on my nutrition profile definition, which means that within the nutrition profile definition class, you can just use constants and they get resolved into actual nutrition element names. But in unit test, because I'm not within that class, I have to do the entire fully qualified name of each of those constants so that they get resolved correctly. So that's what all that stuff is. It looks like I am advocating using regular expressions and string substitutions to parse text. And I'm actually not advocating that, because that is the path to insanity, as it turns out. The problem when we're trying to parse text using regular expressions is that you'll get everything working except one thing, and you get that one thing working and it breaks something else. You get that one working, it breaks something else, and you do that for about 2 weeks, and then you're insane. It's one of those things that seems like a kind of a good idea, but it turns out it's not a good idea at the end of the day. Kind of like this. This is my favorite, seemed like a good idea at the time slide. The thing I love about this so much is you can just see the thought process that went into this. It's really hot out and I'd really like to sit in the pool and barbecue, but the problem is the cord won't reach long enough. And somebody says, well, I've got a power strip. What's really bad about this, you'll notice that is a round plug, so that's a European plug, so that's 220 volts of electricity floating on these two sandals that at any point in time is going to mean that this guy is going to have to go to the hospital. So this is a bad idea. You probably don't want to do this, and you probably don't want to use regular expressions to parse code either, to create a kind of a poor man's parser. Which brings me to the definition of these three terms: polish versus pre-process versus parse. And you see these three words used a fair amount when building DSLs in Ruby. And I've kind of supplied my own definitions for these. There are no hard and firm definitions out in the world. And there are really degrees of how far you go to make stuff actually work. And I'm reminded of a Simpsons episode, actually, when I talk about this. I'm sure you get the Simpsons here, right? There was one episode of The Simpsons where Lisa was thinking about becoming a vegetarian. And one of the things she was doing is she kept imagining have chicken on her plate, and she'd imagine a chicken, and then the chicken breast would kind of fall out on the plate. And she'd imagine a lamb, and then lamb chops would kind of fall out on the plate. And at some point, she imagined a hot dog. And what she imagined when she saw the hot dog was this. This is what made up the hot dog. There was a rat tail, a raccoon feet, a chicken head, and the tongue of a boot went into that hot dog. And that's what a lot of DSLs end up being, is this kind of combination of stuff that you somehow either parse or process or somehow mash around to get into the actual DSL. So here are my definitions of these three terms. Polish, which uses simple string substitutions to convert nearly Ruby to actual Ruby so that you can pass it off to an